In this video, we will factor polynomials of the form x squared plus bx plus c. Notice that this format starts with just x squared, not 2x squared or 3x squared or 5x squared. To deal with something like that, we will use a different video and a different method called the AC method. But we have a quick shortcut to factor things of the form x squared plus bx plus c. To do this, find two numbers that multiply to be c and add to b. These are the constants that end up in the factors. This is a neat trick. It can save you a lot of time. It's possible you've learned this trick before with something called the X method. So I'll do a couple of problems like that and a couple of problems with this wording. First, let's do number 17. We're looking for two numbers that add up to 5 and multiply to 6. Can you think of two numbers that add up to 5 and multiply to 6? Sure, it's 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. So x squared plus 5x plus 6 just equals x plus 2 times x plus 3. Now, this is a nice shortcut. Why does this actually work? The reason this actually works is that x squared plus 5x plus 6 can be written as x squared plus 2x plus 3x plus 6. Now, how would you decide to split up 5x into 2x plus 3x? The way you decide this is this 2 and this 3. If someone asked you to factor x squared plus 2x plus 3x plus 6, you would factor it by grouping, which I covered in the previous video. To factor this by grouping, you'd take out an x from the first two terms, and you'd take out a 3 from the second pair of terms. And then the two groups both have x plus 2 in common, so you'd take out x plus 2. And what's left when you take out x plus 2 from the two groups is x plus 3. Now, we don't want to do factoring by grouping over and over for every little quadratic that we factor. This is called a quadratic because of the squared. So we have this shortcut instead. Instead of doing all the factoring by grouping every time, instead, if it's literally just x squared plus bx plus c, we skip right to the answer after we find this 2 and this 3. Let's do number 18. We have y squared plus 6y plus 8. So you look for two numbers that add up to 6 and multiply to 8. Here the b is 6 and the c is 8. Well, I know two numbers that add up to 6 and multiply to 8. That's 2 and 4. So I just write the answer. It's y plus 2, y plus 4. In number 19, things look a little strange. So I'll first start by writing it in an order that looks more familiar. Addition and subtraction can be moved around. They can commute. So x plus x squared or x squared plus x is all the same. But writing it in this order shows me that b is 1 and c is negative 6. So I'm looking for two numbers that add up to 1 and multiply to negative 6. Oh dear. Okay, well, if the two numbers multiply to negative 6, one of them is positive and one of them is negative. So I'm going to want something like 2 and negative 3 or 3 and negative 2. Like I need one positive and one negative if they're going to multiply to a negative. Which of these add up to positive 1? This one. 2 and negative 3 add up to negative 1. Once I find those two numbers in this format, I'm just done. It's 3 and negative 2. Let's look at some more. This one again is in a strange order. So I'll start by putting it in some standard order. Now I can see that c is negative 36 and b is negative 5. So I'm looking for two numbers that add up to negative 5 and multiply to negative 36. If they multiply to negative 36, one is positive and one is negative again. So maybe like 6 and negative 6. No, those don't add up to negative 5. Maybe 12 and negative 3. No, those add up to a positive number. Maybe negative 12 and positive 3. No. It's negative 9 and positive 4. So the answer is x minus 9, x plus 4. Notice in my answer here, it's not correct. Can you find the error I made here? It's a very common error in these algebra classes. The error I made here is that x minus 9 times x plus 4 definitely does not equal w squared minus 5w minus 36. The question didn't even have any x's in it. And my answer, because I was on autopilot for a minute, is full of x's. No, the variable in this problem is w. Sometimes I'll make mistakes on purpose, just to show you something. But usually when I make a mistake, it's just an accident, and I'll show you the kind of mistake I'll make. And it's the same kind of mistake you're likely to make. So just pay attention to the variables. Okay, number 21 is already in a nice order. I'm looking for two numbers that add up to negative 5 and multiply to 4. Let's organize it like some people have maybe learned in school with a big X. If you organize it with a big X, you put the 4 up here and the negative 5 here, and you're still looking for two numbers that add up to negative 5 and multiply to 4. What kinds of numbers multiply to 4? I mean, 2 times 2 is 4. But 2 plus 2 is not negative 5, so it's not 2 and 2. If you need the numbers to add up to negative 5, they must both be negative. So I guess maybe like, oh no, negative 2 and negative 2 doesn't work. I guess it's negative 4 and negative 1. Now, I usually won't draw this x, but if you've learned it this way with the x, then go ahead and draw an x. Instead, I would normally write that the two numbers add up to negative 5 and multiply to 4, and those two numbers are negative 4 and negative 1. Then I can write my answer. I'll pay attention now and use t as my variable because t is in the question, and I end up with t minus 4 times t minus 1. Number 22 is all in the wrong order, so first I'll reorder it. X squared plus x minus 2. Now I want my numbers to add up to 1 and multiply to negative 2. Since they multiply to negative 2, one is positive and one is negative. And I need the positive number to be a little larger so that they add up to 1. So I will use 2 and negative 1 for my two numbers. So I end up with x plus 2 times x minus 1. Let's look at 23. 23 is all about n. That's fine. Our two numbers need to add up to negative 5 and multiply to negative 6. If they multiply to negative 6, I need one to be positive and one to be negative. So it's not negative 2 and negative 3. Negative 2 and negative 3 add up to the right amount, but they don't multiply to negative 6. Negative 2 times negative 3 is positive 6. So I need a different set of numbers. I guess it's negative 6 and positive 1. This way they still multiply to negative 6, but they also add up to negative 5. So my answer is n minus 6 times n plus 1. Number 24, again, is all messed up in all different order. So let's get it in the form x squared plus bx plus c. The two numbers should add up to b and multiply to c. Well, I need them to add up to a huge negative number, but they have to multiply to be a positive number, so they must both be negative. Sure enough, negative 18 and negative 1 work. So the factors are x minus 18 times x minus 1. Finally, let's look at a trick question, which is number 25. Number 25 has no chance of factoring. Do you see why? The error I made in number 20, where I went on autopilot and started writing x's, but then the answer was supposed to be w, well, this problem has that all mixed up in it. It has m's and x's. So the whole method doesn't work at all. I would say this does not factor. If it was all m's, or all t's, or all x's, then you can use the method. But if the variables are all mixed up, we can't use this shortcut. What do we got on the next page? The next page is the AC grouping method. I'll cover this in the next video.